Welcome to a new video. In this video we are going to create a logistic regression model. So we will define cost function, gradient descent and more by ourselves. At the end of the video I will also show you how we can imply this algorithm with scikit-learn, which is going to be with 1 or 2 lines, which is a great library for machine learning and it's going to be a lot easier. But implementing this by hand is going to give us a lot of depth understanding of the algorithm, and we are going to see part by part how can it be implemented. So we are going to start by importing the libraries that we are going to use. I will say import numpy as mp. I will say import matplotlib.pyplot as plt. I will say plt actually. I don't want errors on that. I will say from sklearn.datasets. I will import make classification. We are going to create our data with that. And I will say from sklearn.model selection. I will import train test split. So we are going to start by creating the dataset we are going to use. We will say x, y, and we will use make classification. Let's set the number of samples is going to be 1000, and number of features is going to be 2, number of informative is going to be 2, and number of redundant is going to be 0, and number of clusters per class is going to be 1. So let's call our x and let's call our y. So we have a binary classification problem, as you can see, since our target is 0 and 1. So we have 2 x's in that side and we can start to implement the logistic regression. Before we dive into the code, let's have a quick refresher on logistic regression. It's a classification algorithm that predicts the probability of an instance belonging to a particular class. The logistic function, also known as the sigmoid function, plays a crucial role in this algorithm. So, before starting to implementing that, let's split our data into training and testing sets, because we are going to train our model on the training data and test its performance on the testing data. So I will say train test split x, y, and test size is going to be 0.2, which means that 20% of the data is going to be in the testing set. So let's say you have 100 data points, 20 will be in the test set and 80 will be in the training set. So that 0.2 means that. So let's start by defining the sigmoid function, like define sigmoid, and we will say let's give z to that. I will say return 1 divided by 1 plus numpy dot exponential minus z. So there's a problem, mp. Okay, I need to change this as mp, and now it's going to be in here perfectly. This mp will like in another color when I rewrite this. Great. So let's initialize the parameters, like we will say theta, and it's going to be numpy dot zeros x train dot shape, and it's going to be 1 after that, and we will say plus 1. So let's call that and see what does it look like. Great. So we are going to add a column of ones to the features for the bias term. We will say x train bias, and we will say numpy dot c numpy dot ones x train dot shape, and we will say 0 after that, and we will say x train in here. And let's call it again like x train bias, and we will see that in here. And let's define a hypothesis function like def hypothesis x and theta. We are going to give x and theta in this function, and we will say return sigmoid numpy dot x and theta. Great. So next step is going to be the cost function. We will say define cost function. We will give x, y, and theta in here. And what we are going to do next is I will set the m as length of the y. And after that I will set the h as hypothesis, x and theta. And I will give the cost as minus 1 divided by m multiplied by numpy dot sum y multiplied by numpy dot logarithm h plus 1 minus y multiplied by numpy dot logarithm 1 minus h. So we will return the cost function we create the cost variable we create after this function, and we are at our final step right now, the gradient descent. So we will say define gradient descent, and we will say x, y, theta, learning rate, and epochs. So after that, we will set the m as the length of the y, and we will set the cost history as an empty list for tracking our performance. After that, we will say for in range epochs, h is going to be hypothesis, x and theta, and gradient is going to be numpy.x.transpose hash minus y divided by m. Actually, I need parentheses in here. I just saw the error before it occurred. Great. So I'm going to set the theta as learning rate multiplied by gradient. Also, we are going to lower the theta with this, so I need to add minus before the equal sign. And now we will set the cost as cost function x, y, and theta. And after that, I need to correct this thing, and after that I will say cost history, and I will say append cost. So we are going to track our cost history like this in here, and we will return the theta and cost history from this. Great, so it's our function for the gradient descent. Let's train the model. Like we will say learning rate, and it's going to be 0.01, let's say, and let's set the epochs as 1000. And after that, what we are going to do is we will say theta and cost history, and we are going to call gradient descent, and we will say x train bias, y train theta, learning rate, and epochs. So there is a problem. Let me quickly check. Epoch is not defined, so epochs actually in here. So now it's going to work smoothly. Here it is. Great. So we have the theta we created, and we have the cost history in here. Like it's going to be 1000 because we set the epochs as 1000, and these theta values are coefficients in the scenario. So let's plot this cost history. Like we will say plt.plot, and we will say range 1 to epochs plus 1. We will say cost history, and let's set color as blue. And after that we will say plt.grid, and let's give the x label like number of iterations, and let's give the y label like cost, and let's give it a title like gradient descent, and let's use plt.show after that. And here it is. As we can see, with the number of iterations increase, which we can also refer as epochs, our cost is lowered, as we can guess. So it means that we increase the number of epochs, we can get a lower cost, but at some point it's going to be slowly lowering. So after some point it's meaningless to train the model with more epochs. So this kind of visualization really helps us on finding the best number of iterations and detecting that point. Great. So that was it for the training logistic regression by hand with only NumPy, and we defined the gradient descent, cost function, hypothesis, sigmoid, and it was it. So we can change these numbers, epochs, and learning rate, and we can observe the differences on the cost function. So let's see how we can easily do this operation, the logistic regression model training, using scikit-learn with a few lines. So I will say from scikit-learn.linear model import logistic regression, and after importing this we can initialize this like sklearn.model, sklearn model logistic regression. Actually it's underscore, not dot, I talked about that. And after that we are ready to use our model, and we can use it easily like sklearn.model. I made the same mistake again, sklearn_model. I'm using this. After that I'm going to use fit, and I will give the training data, and after that we are going to have our logistic regression. by just 1, 2, and 3 lines. You can implement that with hand like this, or you can just use this. These both two methods can be used for training and using a logistic regression model, but in this way you can more specialize it, the parameters, etc. And with this type of thing you can make it easier, and also you can just say scikit learn model dot predict and you can make predictions. Let's say you want to make predictions and the X test. Also you can do that too by hand, but you need to write some code too for making the predictions. Scikit-learn provides ad-hoc machine learning models with really low amounts of code, and it's a super useful library that I use a lot. So you can just use both, but knowing to implement this is a really beneficial, because if you know the basics of an algorithm like this, you will have a better understanding of the data science and machine learning. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I shared a free data science bootcamp where I teach Python, Pandas, NumPy, Matplotlib, Plotly, Seaborn, and Scikit-learn with 3 projects. The video is about 7 hours and it's completely free. You can just reach to that video from the cards of this video or the link in the description.